This is a help video for problem number 1 on your acceleration lesson assignment. How will I find acceleration for my assignment problems? We have 2 steps to calculate acceleration. Step 1, find the change in velocity. The change in velocity is always calculated the ending velocity minus starting velocity. We can't switch those around or we won't get the correct sign for acceleration. And then step 2 is to take our change in velocity and put it over time. Change in velocity divided by time is acceleration. We're going to be thinking about a race in the questions on our assignment. And when we run a race, there are different parts of the race where we are increasing or decreasing speed, accelerating, or stopped. When you run a race, you start from a stop, then accelerate until you reach your top speed. You maintain your top speed through the finish line. After crossing the finish line at your top speed, you gradually slow down, eventually stopping. We will use 2 parts of this race to evaluate acceleration. When you run a sprint, this is Usain Bolt's 100-meter record-breaking race. When you run a sprint, you start from a stop, quickly accelerating to reach your top speed and cross the finish line. Then you continue running, slowing down gradually until you stop. Let's watch acceleration in race. Increasing speed, top speed, cross the finish line, slowing down. If we can keep this in mind, it will help us understand our questions. Question number 1 is about the first part of the race. When you run a race, you start from a stop, then accelerate until you reach your top speed. Step 1 is to calculate our change in velocity. Before we can calculate it, we need to identify our starting velocity and ending velocity. If we are stopped waiting at the start line for the go signal, what is our velocity? If we are not moving forward, backward, if we are stopped, our speed is 0 meters per second. Our starting velocity is 0 meters per second. We accelerate from the go signal until we reach our top sprinting speed of 5.4 meters per second. What is our ending velocity? For this part of the race, the part of the race that applies to question number 1, our ending velocity is our top sprinting speed. Our top sprinting speed is 5.4 meters per second. Question number 1 is just the first part of the race. To get the change in velocity, we take our ending velocity minus starting. The ending velocity was 5.4 meters per second. We subtract the starting. We must do it in this order to get the correct sign for acceleration. 5.4 minus 0 is positive 5.4 meters per second. Our change in velocity is positive 5.4 meters per second. Before going forward, let's make sure the answer makes sense. If the change in velocity is positive, then speed should be increasing. Is speed increasing in this part of the race? This part of the race is from the start line to top sprinting speed, shortly before the finish line. Speed is increasing in this part of the race. So positive velocity answer in terms of change in velocity makes sense. Yes, this answer makes sense. Our step 2 is over what time? Acceleration equals change in velocity over the time it takes for the change to occur. You're standing next to your friend, ready to race across a field. When the go signal is given, you take 5 seconds to get to your maximum sprinting speed. Our time is 5 seconds. To calculate acceleration, we take our change in velocity and divide it by time. Positive 5.4 meters per second divided by 5 seconds gives us acceleration equal to 1.08 meters per second squared. And this is positive. Our acceleration is positive 1.08 meters per second squared. Does this make sense? If we have positive acceleration, that means our speed is increasing. Is speed increasing in this part of the race? Yes, it makes sense. We used 2 steps to calculate acceleration for question number 1.